Lesson 4.3 is often notorious in my classroom because it's on the dreaded division of polynomials. Up until now, we have added polynomials. So if I gave you something like this, plus, we know that we could combine like terms and add them together. We could also do the same thing if we did subtraction. And we've also done multiplication, where like if I had something like 4x minus 3, and I want to multiply it by x plus 2, we would FOIL that together. The only operation we haven't really talked about with polynomials is division. So like today's lesson, we'll focus on if I had something like 4x squared plus 5x minus 3 divided by x minus 8. And I wanted to know, what does that actually come out to? Because again, sometimes it's easier to work with one polynomial than two separate ones. So when we can simplify, we always try to. So the first big objective, and this is the one that my students kind of dread, but once you get the hang of it, it's really not that bad, is to use long division to divide them. Now, good news is we're going to look at a different way as well. So if you're not a fan of long division, all is not lost. There's another way called synthetic division. And then the final two objectives are looking at, I guess we could call them kind of like special rules that will always happen when we're dealing with division. So, long division. Oh my, the last time you probably did this was back in grade school. So what I want to do before we even bring in the polynomials, I would like to do this first with just regular numbers. So let's say I wanted to take 5 and divide it into 820. And I want to know what would come out. So remember, when you do long division, you take your 5 and you look at the first number. How many times does 5 go into 8 without going over? You should say once. So we place our 1 up here. Then we take 1 times 5. And then we're trying to figure out what is the remainder, or how much is left. So we're going to subtract that out. So 8 minus 5 is 3. I'm going to bring down the other numbers. We're going to repeat the process. So how many times does 5 go into 3? Well, it doesn't go into 3, so I'll go to the next number. How many times does 5 go into 32 without going over? You should say 6, because 6 times 5 is 30. So we'll place our 6 up here. We're going to multiply it. 6 times 5 is 30. And then I want to figure out what's left, so I'm going to subtract. If I subtract, I have a 2 left. I'll do a different color here. A 2 left, and then I'll bring down the 0. And we're going to start the process again. So how many times does 5 go into 20? 4. So we place the 4 up here, multiply it back in. 4 times 5 is 20, and then we subtract. Notice at the end I get 0 out. That represents the remainder. So this means it divided in clean. I do not have a remainder. So my answer, if I wanted to know what is 820 divided by 5, well, the answer is 164. If you can do that, we're going to do that exact same process, but with polynomials. It's going to work the exact same way. So let's look at this first example. Divide using long division. Now I do have a typo in this problem that I want you to fix. In the first polynomial, it should say x squared plus 10x plus 21. Please change that to a plus. So if we're going to set up this division, what we will do is we'll have our x plus 3, and we want to divide that into the x squared plus 10x plus 21. We're dividing into that polynomial. So here's what I tell my students to do, and I'm going to color code this to kind of help you keep track of what's happening where. I want you to focus on the leading term, so the term with the highest exponent, in this case it's x to the first, and I want you to focus on the leading term inside the division, so the x squared. So what we are going to do is we're going to divide. Just like up top when I did 5 into 8 was how much, so I basically took 8 divided by 5. We're going to do the same thing here. So I want you to think x squared divided by x. I'm dividing the x in. Ignore everything else. So x squared divided by an x, remember we subtract the exponents, we'd have just an x left. So that's what I'm going to write up top. And now just like what we did up top, once we wrote a number up top, we multiplied it back together. So I'm going to take my x and I'm going to multiply it back to the x plus 3. So x times x would be x squared. X times 3 would be 3x. So I multiplied it through. What did we do next? Well, once we wrote down a number, so when I wrote down my 5 up there in blue, I subtracted it to figure out what was left. So that's what we're going to do here. We are going to subtract this red quantity, so what ends up happening, this becomes a minus, and this becomes a minus. I'm changing the signs. So if I do that, notice the first set cancels out when I combine like terms. That will always happen if you're doing the long division correctly. 10x minus 3x, I'd have 7x. And then I'm going to bring down the 21. I'm going to start this process all over again. So I'll do a different color here. So I'm going to take the leading term, the x, and the leading term, the 7x, and I'm going to divide them. So I'm going to think 7x divided by x. What would be left? 7. So I'm going to place my positive 7 up top. And now I'm going to multiply the 7 back through. So 7 times x, 7 times 3. Then what did we do? We have to subtract because I want to figure out what's left. So this becomes minus, and this becomes minus. The first set cancels out when I combine my terms. That will always happen. Now the next set, if I combine those, they also cancel and I have 0. What does that mean? Well, I'm done. I know I'm done with this problem because notice there's no other numbers to bring down. And this represents my remainder. I don't have a remainder on this problem, which means this polynomial divided in cleanly. So my answer, if I asked you to tell me, okay, what is the answer after dividing these two things? It's x plus 7 is the result. Okay, we're going to try another one. So this time I want to take that first polynomial and divide by 3x minus 2. So let's set it up. My 3x minus 2 out front. Now be really careful here. Notice when I write the polynomial inside, I would like to write it in standard form. So I want to write it in order of the exponents. So the first term I'm actually going to write is 6x cubed. Oh, what is it doing here? And then I'm going to write my minus x squared, and then my minus 5x, and then plus 4. So I'm writing it in decreasing order of the exponents. That'll help with the division. All right, we're ready to begin. So leading term, 3x, leading term, 6x cubed. I want to divide those. So I want to think 6x cubed being divided by a 3x. What would be left? And you should say a 2x squared. So that goes up top. And now I want to multiply that 2x squared back through. So 2x squared times 3x would be 6x cubed. And 2x squared times negative 2, negative 4x squared. Okay, what happens now? Well, I need to subtract. I want to figure out what's left. So I'm going to minus. Now notice this one is minus. So when I subtract a negative, that actually turns positive. So you're basically changing the signs. The first set cancels out, which should always happen. Combine like terms, negative 1x squared plus 4x squared would be 3x squared. And I'm going to bring down the other two guys. And now we start again. Switch colors here. So I'm going to take my leading term, 3x, and my leading term, 3x squared. I want to divide 3x squared being divided by a 3x. What would be left? Well, 3 divided by 3 is 1. X squared over x, I'd be left with just a 1x. So that guy goes up top. Now we're going to multiply the x back through. So x times 3x, 3x squared. X times negative 2, negative 2x. We're going to subtract, so change the signs, change the signs. First set cancels. Combine like terms. And I'm going to bring down the plus 4. And we're going to go again. So I'm going to take the leading term, 3x, and the leading term, negative 3x, and let's divide them. So negative 3x divided by a 3x. What would be left? Should be a negative 1. And now we're going to multiply the negative 1 back through. So negative 1 times 3x, negative 1 times negative 2. And now we're going to subtract to get the leftovers. So we change the signs, so that becomes minus. First set cancels, and I'm left with a 2. Now, I know I'm done because notice there's no other numbers to bring down. Also, another way to know that you're done, I cannot take 3x and divide it into 2. That won't work. So this is my remainder. This time I do have a remainder. So here's how I want you to write your answer if you have a remainder. After dividing, my answer was 2x squared plus x minus 1. And if there's a remainder, here's how we write it. Plus my remainder of 2 over what I was dividing by. So I was dividing by the 3x minus 2. And you might think, well, that's kind of strange. Why do we write it like that? That just really makes the answer look intense. Well, I'll tell you, back in grade school, you always wrote your remainders like that. Example, if I had 8 divided by 5, and we wrote that as a mixed number, you would say, okay, how many times does 5 go into 8? Once. And how much was left over? Well, 1 times 5 is 5, and there's 3 left over. So that's the same as 1 3/5. Notice what you did. You put the remainder, the leftovers, over what you were dividing by. It is the same concept with polynomials. It just doesn't look as nice. I want to do one more just to really make sure we have these steps down, because if you can handle long division, the shortcut way that we're about to do next, cake. And you might say, well, I don't like cake. Well, you're going to eat it anyway, and you'll love it. So let's set it up. So out front, I'm going to have my 3x squared minus 2x. Now this one's kind of a trick, because notice it is written in standard form, decreasing order of the exponents, but something's missing. So if I start, I have my 6x to the 4th, I have my 5x cubed. Notice though there's no x squared term. They went from x cubed to x to the 1st. What I highly, highly recommend, and you'll see why this is helpful, if they skip a term, if something is missing, let's use a 0 placeholder. It is going to make the math so much easier. So I'm going to use a 0x squared, and then my 3x, and then my 5. I will show you why it's helpful to do that. You don't have to do it, but I think you might get more confused. So here we go. Leading term, leading term. 6x to the fourth divided by 3x squared. I would have a 2x squared left. Now we multiply that back through, so 2x squared times 3x squared, 6x to the fourth. 2x squared times a negative 2x would be negative 4x cubed. Now we change the signs, so minus, plus. First set cancels, and now let's combine what's left. So we have 9x cubed, 0x squared, 3x minus 5. And now we're going to start over. So highest term, 3x squared, and highest term, 9x cubed. Let's divide. So if I divide those, I get 3x. Multiply 3x back through, so 3x times 3x squared would be 9x cubed. 3x times negative 2x would be negative 6x squared. Here's why it's helpful to do that 0 placeholder. If I wouldn't have had that 0x squared there, I would have nowhere to line up this negative 6x squared with, and then I could mess up the math. So it's nice to use the placeholder because it helps things line up. Change the signs. So 6x squared plus 3x minus 5, and we're going again. So leading term, 3x squared, leading term, 6x squared. Go ahead and divide them. And I'm left with just 2. Multiply the 2 back through. Change the signs. First set should cancel. And if I combine what's left, 7x minus 5. Guess what? I'm done. How do I know I'm done? Well, if I tried to do dividing again, if I tried to take the 7x divided by 3x squared, that's not going to go in. The exponent on the bottom is bigger. That's not going to divide. So what that means is this entire thing is the remainder. You can have multiple parts to your remainder. So how we would write our answer is 2x squared plus 3x plus 2 plus my remainder 7x minus 5 over what I was dividing by. So not a pretty answer, but that is the result. All right, so let's look at the other item on the agenda. Long division, let's be honest, long division can be a pain in the butt and it takes a long time. So again, mathematicians are always on the lookout for those shortcuts. They created another way to divide, which really speeds up the process. However, here's the downfall, because you might think, well, if this way is quicker, why don't we just do it all the time? This new way called synthetic division can only be used if you are dividing by something that is linear. What do I mean by linear? Well, the highest exponent can only be a 1. So like on that last one we did, notice I was dividing by something that was quadratic. Highest exponent was 2. The shortcut way will not work. You have to use long division. But if it's linear, we're going to use the shortcut way to speed things up. So here's how it works. I'm going to set up my synthetic division, and different books and different teachers do it different ways. If you've learned this another way and that way makes more sense to you, please do it. Here's the way that I do it. So my division box kind of looks upside down from what it was, and you'll see the purpose of that in just a moment. So now one of the parts of the shortcuts to synthetic division is to not worry about the variables. So what we're going to do on the inside of my division here, I'm only going to use the coefficients and ignore the variables. So I'm going to have a 5. Now notice though, they skipped something. I don't see an x squared term. We have to use a 0 placeholder for the x squared, or you're going to get the wrong answer. And then my 6, and then my 8. So I'm just using the coefficients, just the numbers. Now out front, we're going to divide by 2. But here's the catch. Remember when I did long division, every time I brought numbers down, I would always change the signs, change the signs, change the signs. Well, part of the shortcut to synthetic division, rather than changing the signs every time, the number that we're going to divide by, we're going to turn it opposite right away. And then we don't have to change the signs every single time. All right, so we're ready to begin. What we're going to do first, this very first number, you're going to bring it straight down. We're going to drop it like it's hot. Okay, bring that 5 straight down. Don't do anything to it. Then think in long division, once we had a number written up top, because we're kind of doing it in reverse, we would multiply it back in. So we're going to take this 5 and we're going to multiply it by -2. 5 times -2, -10. And then this is where normally we would have changed the signs. Don't change the signs. Just combine them. 0 plus -10, -10. Now we're going to multiply -10 times -2, 20. Now we're going to combine them, 26. Now I'm going to take 26 times -2, -52. And now we're going to add them, 8 plus -52, -44. Guess what? We're done. This has been divided. So what we are actually going to do next is write this as a polynomial, and we'll have our answer. So to write this as a polynomial, notice the highest exponent was cubed, and we've divided by an x. So our answer is going to be 1 less than the exponent of the original. So we're going to have 5x squared minus 10x plus 26. And you might have guessed it, this last number here is the remainder. It represents the remainder. So we're going to write our remainder over what we were dividing by. And we're going to use the polynomial form, x plus 2. So here is my answer. Now, if you wanted to know if you were right, you could double check that with long division. Okay, let's try another one. So I'm going to set up my synthetic division. I'm going to put my coefficients 10, -13, make sure it's negative, 5, -14. Notice they didn't skip any terms, so I don't need a 0. Out front, I'm going to do a +3, because right now it was -3, but I'm changing it right away. Okay, the first number, we're going to bring it down, drop it like it's hot. And now we're going to multiply 10 times 3. And now we're going to add them, combine them together, so -13 plus 30. And now we're going to multiply 17 times 3. And now we're going to add 5 plus 51. And now we're going to multiply 56 times 3. And now we're going to add. So it's back and forth, multiply, add, multiply, add, multiply, add. And we're done. We have our result. We're just going to write it back as a polynomial. So if I look, originally the highest exponent was x cubed, but I've divided by an x. So now it's going to be 10x squared plus 17x plus 56. And that last number is my remainder. So plus 154 over what I was dividing by. I would get this same answer if I would have done this problem using long division. It's just a lot quicker this way. The final few things I want to talk about are two, I guess we could call them rules or theorems. One of them is all about remainders. So it says if a polynomial, let's just call it f of x, we'll use function notation, is divided by some kind of linear polynomial, like what we were just doing, it says then the remainder has to be f of c. What? What does that even mean? Well, probably the easiest way that I can explain this to you is to do an example, and then we'll talk about this rule. So, use the remainder theorem and synthetic division to find the function value. Up until now, if I would have given you a polynomial and I would have said, hey, find f of 3, what you probably would have done, we know this means x equals 3, so we would have substituted 3 in. Let's actually do that really quick. So if you were to plug 3 in for all the x's, oh boy. So if I plug 3 in for all the x's and I want to know what is my answer that comes out, well, if you did that in your calculator, it's going to be a big answer. F of 3 would come out to 711. Now that is the answer. That is what this problem wants. It wants to know what was the value. However, I want to show you another way that we can get that answer, and that's what this property up above is talking about. I would like us to set up synthetic division. So inside I would have my 4, -3, 1, -6, 8, and -15. They didn't skip any terms, so I don't need a 0. Out front, I'm going to have 3. Now, here's sometimes where my students get confused. I'm not actually going to turn that 3 opposite. It's already been turned opposite because notice when it's written in this form, this f of 3, that literally means x equals 3. What we were doing before, it was in this form, x minus 3. So it's, I guess you could think of it as when we turned it opposite, it's like we solved it, which is why we turned it opposite. Since it's already x equals 3, I don't actually want to change it. I want to use that actual value. So bring down the 4, drop it like it's hot. Multiply 4 times 3. Add. Multiply. Add. Multiply. Add. Oh, wait, I messed up. 3 times 28 should be 84. Then add them and we get 78. Multiply 234. And then 242. 726. I wonder why this is called the remainder theorem. Well, look at the remainder, the last number. See how that answer was the same exact answer as if I plugged the number into the function itself. That's what this rule is saying. That will always happen. So it's a way to kind of double check your answer. If you don't think you did it right, you now have 2 different ways to get there. All this rule says is the remainder should be the same thing as the answer you get from just substituting the number in. That's why it's called the remainder theorem. And the last one you already know about, you probably just have never thought about it this way. It's called the factor theorem. A polynomial, let's call it f of x again, has a factor of x minus c if and only if this happens. What does that mean? Well, it looks like when I plug this number in, this magical c, I get 0 out. Another way to think of this is the remainder equals 0. So let's think about it. You already know this. If I said, hey, suppose I have the number 12, and I said, hey, is 7 a factor of 12? You should say no, and if I said, okay, why is 7 not a factor of 12? You would tell me, well, 7 doesn't divide cleanly into 12. There would be leftovers. If I said, hey, is 6 a factor of 12? You would say yes, and I would say why? And you would say, well, because 12 divided by 6 is 2. It divides in cleanly. There's no remainder. That's all this rule is saying. If something is a factor of something else, when you divide it in, you better get a remainder of 0. If you don't get a remainder of 0, it's not a factor. Let's try it. Solve the equation given that 3 is a 0 of this equation. So if I kind of look what we were doing earlier, notice the highest exponent is a 3. That means I should be expecting 3 answers. We talked about that earlier. So they've given me one of the answers. They said x equals 3 is a 0. Remember, they're called zeros because they make the function 0 when they're plugged in. So there's one answer. I'm looking for 2 more. Well, here's the beautiful thing about division. If I know this first guy is already a 0, what I'm going to do is I'm going to set up my synthetic division, or you can use long division. I'll let you pick. We'd have 2, -3, -11, and 6. Out front, I would just want to put a 3 because it's like it's already been solved. The only time you want to change it opposite if it's in like this form or this form. If it's already equal to something, just use it. Bring the first guy down, drop it like it's hot. 3 times 2 is 6. Add, multiply, add, multiply. Now notice what happened. The remainder came out to 0, which it very well should, because we said 3 was a 0. If you don't get 0 out, then you did something wrong. Well, why did we do that? Well, let's look. If I write what's left as a polynomial, it was x cubed, so I'm going to now have 2x squared plus 3x minus 2 and no remainder. I can finish solving this now. So remember to solve, since this is quadratic, we could factor it, we could do the quadratic formula, we could complete the square. If I had to pick, I would try factoring first, because to me that is the quickest. Let's see if this will factor. So I want to multiply to -4, and I want to add to 3. I need 2 numbers that multiply to -4, but they add to 3. Should be a 4 and a -1. So let's rewrite it. And now we're going to group. From the first group, from the second group, remember I need to get my groups to match. They both now have an x plus 2. The other group would be 2x minus 1. And since it actually wants me to solve, I have to finish this. I'm going to set each piece equal to 0. So subtract 2, I get -2. Add 1, divide by 2. There are my other 2 answers. So total, if I was answering this question, I would say my answers are 3, -2, and 1/2. They gave me one of them, I found the other 2. If you still weren't sure if you did this right, if you check any of these answers with synthetic division, you better get 0 out as the remainder, because that's what a 0 means. It's a factor.